The McClure Books problem is an application of the news vendor model where we are asked to forecast demand for a particular book, assuming a normal distribution around a given mean and standard deviation. Part A asks us to determine the probability that the book will be a blockbuster, meaning it would sell more than 400 copies. Because we know that the forecast is represented by a normal distribution, we can convert that order quantity into a z-statistic using the formula quantity minus the mean forecast all over the standard deviation forecast, or 400 minus 200 over 80, which is equal to 2.5. We can then use the standard normal distribution table to convert that z-statistic into a probability of 0.9938. This represents the probability that fewer than 400 copies will be sold. So to convert that into the probability that more than 400 copies will be sold, we'll subtract this probability from 1, which gives us an answer of 0.0062. Part B will use the same formula, except now we're trying to determine the probability that the book will sell fewer than 50% of its mean forecast of 200, which would mean less than 100 copies. So 100 minus 200 all over 80 is equal to negative 1.25. Again, looking that up in the standard normal distribution table, we get a value of 0.1056. So there's a 10.56% chance that fewer than 100 copies will be sold. In Part C, we're trying to determine what the probability that the demand will be within 20% of the mean forecast. 20% less than 200 is 160, and 20% more is equal to 240. So we'll use this same Z formula to calculate statistics for each of these demand quantities. For 240, we get a z-statistic of 0.5, and for 160, we get negative 0.5. Looking these values up in the standard normal distribution table, we get a probability for 0.5 of 0.6915, and a probability for negative 0.5 equal to 0.3085. The probability that the forecast will fall within this range then is the difference between these two, or 0.3830. Next, Part D asks us to maximize profits. In order to do that, we're looking for the order quantity in which we minimize the costs of ordering too many units, as well as the opportunity cost of ordering too few. This is represented by the critical ratio, which is the ratio of the underage costs over the sum of both the underage and overage costs. Starting out with the underage costs, that's equal to the opportunity cost of not ordering a unit that could have been sold, or price minus cost. So in this instance, that's equal to 20 minus 12, or $8. The overage cost, on the other hand, is the loss incurred when a unit is ordered but not sold, and is represented by the equation cost minus salvage value. Because here we know that the salvage value is 12 minus 4, which is equal to 8, and that's because Dan can return leftover books for a full refund of $12, but incurs a $4 cost of shipping and handling. So therefore, the overage cost is equal to 12 minus 8, which is equal to 4. The critical ratio is therefore equal to the underage cost over the underage cost plus the overage cost. That's equal to 8 over 4 plus 8, or 0.667. In the standard normal distribution function table, we see that 0.6667 falls between the z-values of 0.43 and 0.44. But we can use the roundup rule and choose the z that's equal to 0.44. Finally, we can convert this z into an order quantity using the formula that the mean plus z times the standard deviation, or 200 plus 0.44 times 80, which is equal to an order quantity of 234.2 units. Please see Part 2 of this video for the answers to Parts E, F, and G.